Okay, next one is polynomial functions. A polynomial is an expression with variables and coefficients. Now variables is x and y's, like pronumerals, and coefficients are constant, just values and numbers. So let's have a look. For example, y equals 4 is a polynomial. Y, if it's a constant, but we can write it like this. Y equals 4x to the power of 0. Now, of course, x to the power of 0 is always 1. So even we can't see anything here, we can actually put the variables here with the power of 0. So that y equals 4 is polynomial. It's also expression. Okay? But what about this one? Y equals 4x to the power of -1. It's not a polynomial. Why? Because the power, which we call it degree here, need to be non-negative. So this is a negative power. Therefore, this cannot be polynomial because the power, the degree has to be non-negative. Non-negative meaning it can include 0, 1, 2, 3, and so on. So this one has a power of 0, therefore this is a polynomial, but this is a negative, so it's not a polynomial. Okay, I'm going to push this one up a little. Go to the next one. Now this is a polynomial. So I've got two ways of writing the polynomial here. The first one, I wrote it as a number, which we are familiar with, and this is like a general term using pronumerals. Like an is coefficient, which is similar to here is a 2. The one that a number in front of the expression in terms of x with a power here. Now, so that's 2 is like equal to equating, if you would like, a to power nth term on there, and then this is the leading term. Whole thing is a leading term, and the power is n, which is a 6 here. And then if you look at the 4 here, and then a to the term 0 here, that's a constant. Okay, that's a constant term. Now what happens here, a previous that is a and the term 1, first term, and x. And that x has a power of 1 here. Okay, so that you will see it's matching up, and nth term is n power, n minus 1 term is n minus 1 power, and so first term is a power of 1. Now here, a to 0 term, which will be x to the power of 0. Again, similar thing as what we did for example, y equals 4. That this, we don't write x power of 0 anymore because it's 1. So that becomes just constant term here. Okay, so let's have a look a little bit more detail now with the terminology of the polynomial here. Okay, here we go. So a nth term, this is what we call leading coefficient. Why? Because it's got the highest power, highest degree n. So one that's coefficient for the highest degree is what we call leading coefficient. Okay, and the leading term is the whole thing. Okay, that's our leading term. So for example here, our leading term here is 2x to the power of 6. That's our leading term. Okay, and the constant term here is 4. Constant term is a to 0 term. Okay, and of course the highest power, what we call is degree. Okay, n degrees. Let's move it up a bit. Okay, so if the leading coefficient equals 1, polynomial is called a monic polynomial. I think we've done it with the monic quadratic equation. So monic means 1, so coefficient is 1. Okay, go to the next one. Push it down. let's have a look at the examples now. Let's do the examples, guys. Okay, let's see. Yep. I'm going to just cover this one so we can do one at a time. So, which of the following are polynomial expressions? Okay, so A, B, C. There's 3 examples here. Let's have a look at the A. 4 minus x plus 3x squared. 3x to the power 4 minus x squared plus 5x minus 1. And the C is x squared minus 3x plus x to the power of negative 1. I mean, when you look at it, I can say that is correct. That is correct, but not this one. Why? Because it has negative power. Like what I said before, negative power is not an expression for polynomial. Okay, next one. Part B, we got this polynomials given, and we need to answer all those parts here. So find the degree of polynomial, the highest power, which is degree equals 6, because that's the highest power is 6. Is the polynomial monic? Yes, because the leading coefficient is 1, so yes, it is. And state the leading term. Now, leading term will be x to the power of 6. And what is the constant term? At the end, that would be minus 3. Find the coefficient of x to the power 4. X to the power 4, the coefficient is minus 2. Yep, that wasn't too bad. That was easy. Okay, go to the next one. I'll just put this away. So let's have a look at, push it down a bit. Now we're going to do polynomial equations. Now when we say equations, you need to have equal sign, okay? Otherwise we won't call it equation. So that's what it means. Now the examples. Find the zeros. Yes, find the zeros, meaning roots, that's another way, or solutions. Okay, that's what it means. Of the polynomial x squared minus 5x. Now, to find roots or zeros or solutions, you need to make polynomial equal to 0. That's what we're talking about here, is the equation. Okay, so let's have a look. If I put that in, and what is a common factor? X. So I take x out, I will have x minus 5 equals 0. Of course, it's either this is 0 or that would be 5. Okay, so don't forget to write your answer in terms of what the question mentioned. It is okay to write x equals 0, 5, but a proper way is actually answering the question, using the term from the question itself. So zeros are 0 and 5. So roots are 0 and 5. Next one. This is the proving question. Show that the polynomial p of x equals x squared minus x plus 4 has no real zeros. Now, when it comes to no real zeros, you probably remember these terms from the quadratic equations and something called discriminant. So something like this. Discriminant b squared minus 4ac is less than 0. This is coming from quadratic formula. Do you remember quadratic formula? B plus minus b squared minus 4ac all over 2a. Now, that under the square root, that's the discriminant. This gives you information about roots, okay, zeros or solutions. So it has to be less than 0 to have no real zeros. So let's have a look. From the polynomial, a, b, c are the coefficient of the quadratic equation here. So a is the 1, b is minus 1, c is 4, and I'm going to put that into the b squared minus 4ac. I substitute back in, and I will get minus 15, which is less than 0. So how am I going to finish this question is writing the actual sentence, because it actually says show that has no real zeros, so therefore the polynomial has no real zeros.